Okay, so just to introduce myself, first of all, I'm Mark, and I'm from the UK, and I work as a kind of developer, consultant sort of character in there. I typically work with customers who want to work out how these tools kind of fit together and train their team up and so on. I also am one of the kind of co-chairs of the ODTUG BI DWC and also the equivalent thing in the UK as well. I'm also, if you're interested in this session and want to talk through some of the kind of features and techniques in more detail, I think I'm in the OTN lounge at 12 o'clock today doing an hour there, so if I come along and chat to me then, and I can go into a bit more detail on what this is all about. So, you know, what is this session about really? What is the kind of context here? Now, if you've gone out and bought Oracle BI Enterprise Edition, really the kind of best possible data source for it would be a kind of proper data warehouse that's been set up with facts and dimensions and materialized views and indexes and so on. And that should really be your kind of objective really in terms of the data that's going into OBIE. And you might use, for example, Oracle's Business Analytics Warehouse to do that, or you might go and build your own data warehouse. But what I tend to find, especially at the start of a project or during the kind of the prototyping phase of a project, the warehouse might not be in place at that point. And so you've been asked by your boss or someone to put some data into OBIE. That data might currently be, say, a normalized kind of database or a data warehouse that's not quite set up kind of how you want it. And so what this session is about really is how you can use the features in OBIE and BI Server, the administration tool, to kind of model your data so that it kind of closely fits what you need to sort of see in OBIE. And really the kind of BI Server is a pretty kind of interesting technology because it has a whole bunch of features that you can use to take your data wherever it is, whether it's in a warehouse or whether it's in all different systems, whether it's in an S-based view, even in files or XML, and transform it into, in a way, a kind of virtual data warehouse, which you can then report on using dashboards and answers, or even business objects, cognos, and so on. And there are kind of features such as federated queries, fragmentation, aggregate persistence, and so on. All these kind of features you can use in this kind of data modeling context. And that's what we're going to talk about really in this session. So just to give me an idea really of kind of where you're coming from, can I just have a quick show of hands? Who here is currently a developer using OBIE? So who works with the tool at the moment? Okay, so that's good. Who's got a background saying Discoverer? Anybody who uses Discoverer? Okay, so one of the things we'll look at later on is how you can take data that you typically report on in Discoverer, which may not be a kind of a star scheme, it might be kind of set tables with kind of self-joins and kind of, you know, fan traps and so on, how you can take that data and also kind of make it compatible with Oracle BIE. So hopefully you'll find this interesting. One of the things I've done, I've noticed that the kind of the title of the slide isn't kind of data modeling best practices, it's techniques, because data modeling is a bit like performance tuning. It's one of those things where everyone's got an opinion and everyone does it differently. So what I'm going to go through is what I've found works for me, but I can welcome questions and comments as we go along. And if you think, well, actually you've got that wrong, or there's something you can do this better, then call out and we can kind of discuss it as we go along. So just to kind of set the context, what we're talking about here is we're talking about Oracle Business Intelligence Enterprise Edition, and in particular, one of the servers that comes with it called the Oracle BI Server. And this is basically a server engine that sits on top of either one or more data sources. So it could be a data warehouse, it could be a business suite, it could be one of your own applications. It takes those data sources, it combines them together, it creates this kind of metadata layer over them, which means that you can define a sort of single continuous business model over all your data. And then this business model is then presented out to the query tools, so the dashboards and answers and so on, so that your users can run queries and see the data. Now, kind of architecturally, OBIE has kind of a number of servers, and the one that we're looking at is the one that's in the middle, which is this Oracle BI Server. And when I heard about this product at the start, so when I actually started working with OBIE first of all, this was really interesting to me because my background was in data warehousing and discovery and so on. And there was this thing called the Oracle BI server, which is kind of interesting. So what does that do? And how does that relate to the database? And what was also interesting was looking at it, it had a whole bunch of features and functionality that really kind of were duplicates of what's in Oracle. So you had summary management, you had kind of caching, query parsing, a whole bunch of stuff. And for me, one of the things that I was kind of interested in at the start was, well, okay, so you've gone out and licensed OBIE, you've got the BI server, you've got the data warehouse. At what point do you use the various functions? Do you now do all your summary management in the BI server? Do you create all your queries in the BI server? Or do you not use any of those features? So hopefully what I'll kind of cover in this section is really kind of why I think we use what feature and where. So you've got the BI server, and you've got the presentation server, which is what produces the dashboards and the reports. And then you've got various things around alerts and kind of publishing and so on as well. But what we're going to focus on is this thing called the BI server. Now, the BI server does many things, but one of its kind of key capabilities is the fact that it can connect to all different data sources. So it connects to Oracle, SQL Server, Teradata, DB2. It also connects through to multi-dimensional databases like Essbase and analysis services. And what it does is it connects to all these sources, and then what you do as a developer then is you tell the BI server how to combine these sources together into a single model that describes your business. And so kind of that's one of the things it can do. Now, obviously if you get the BI server to combine your data, then you could potentially get a performance hit compared to maybe you doing that as part of the data warehouse load. So we're going to look at really kind of how you can do this within the BI server. We'll also talk about a kind of roadmap to go on from there really. So the context of this really is that we're going to show you how you can use the BI server tool to do this kind of combining of data and modelling and so on into a kind of single star schema. Because it's a star schema that really BI server wants to work with in the end. So you could potentially give it at the start all your different data sources, and it expects you then as an administrator to find a way to turn that kind of disparate set of tables into a star schema. And this comes back really to the kind of origins of the product. When this was developed 10 years or so ago by a company called Enquire, they originally sold this or positioned it as being a search engine, because it was at a time when everyone was into search and there wasn't really a clear leader in the same way there is now with Google. And Enquire's kind of proposition was that it's very easy at that point to search for unstructured data in your kind of system, your organisation, but the structured data, the kind of the GL data and measures and so on, at the time was harder to find. So their kind of thinking was, let's create this kind of engine called the Enquire Query Server that you can then map it to all the different data sets in your organisation. You then create this metadata model in the BI server that basically brings it all together and describes it in a kind of Kimball style dimensional model. And then the queries go against this model, and the model then gets translated, queries get translated from that model into SQL statements against Oracle, against DB2, against kind of SQL Server, and so on. So the kind of thing that makes this all possible is the metadata layer, which is called the Common Enterprise Information Model. And this is a kind of three-layer metadata system that at the bottom layer has all the connections through to your different data sources, so Oracle, DB2, analysis services, and so on. You then define things like keys and foreign keys in that layer. You might, for example, alias the tables, and we'll look at later on why you want to do that. So you have kind of, typically kind of 2 or 3 or 4 different data sources coming into the physical layer. Then what they call this, it's called various things, but it's often called the semantic object layer, or I call it the kind of business model layer. That's the model where you take this kind of quite complicated set of kind of source tables and model it into a much more simplified star schema. And you also define within there the kind of the drill paths, any calculations. You might manage summaries in there as well. You can do things like time series calculations. So really the kind of focus of what we're going to look at with you today is working in that middle section, that semantic object layer or business model layer. And then what you do, the idea is you define one model to really describe your entire business. And then what you do is you basically take sort of elements of that, so subsets of that, and create kind of separate presentation layer models for particular audiences. So you might have a finance audience, a kind of analyst audience, and so on, who then view a sort of a subset of that overall business model. So really, the techniques that we're going to do, and your objective really as a developer in OBIE, is at least in the kind of middle layer to get to the point where your data model is a star schema. And this is something where, I see a bit of confusion, say, back in the UK, where customers potentially don't realise this is a requirement. So, your source data can theoretically not be in a star schema. Okay, but your job really as a developer is to then take that kind of set of normalised tables and turn it into a star schema. Now, in an ideal world, your source data will already be a star schema, because then the mapping work that goes on, the translation work is minimal, and your data is already organised into denormalised kind of dimension tables and facts and so on. And you can take advantage of things like bitmap indexes, star transformations, various kind of techniques in the database that make kind of access to star schemas, very kind of optimal. So your objective is, to have a star schema. Ideally, your source data is already a star schema, but it may not be. And certainly in the first kind of prototype phase, you may just be given a set of data by your bosses or by sort of a client or whatever, and they say, we'd like to see that in OBIE. Can you kind of work some magic so that you can transform it using the kind of administrator tool so it looks like a star schema? And that's what we're going to look at really in this section. The other thing you can do is your data might not only be not in a star schema, but it might actually exist in different physical databases. So you might have, for example, some customer data in Siebel, some kind of product data in Oracle, maybe kind of some budget data that sits in Essbase. And so one of the features of the tool is this thing called federated queries, where you can model a kind of a logical fact table that contains actuals and kind of the budget data. It can then map onto separate physical databases. And then when the query comes through, Oracle will then generate two SQL statements, one that's maybe an Oracle one that's maybe a SQL Server one. They'll be kind of natively kind of written, so if Oracle will support like ranking, for example, there are certain things in SQL Server, presumably that are unique to it. And then the BI server then combines these together. Now again, ideally your data would already be integrated. You'd use a tool like Warehouse Builder and you'd already integrate it, and that would really be the first message that, the closer you can get your source data to this kind of simplified star schema, the better. But it's still useful as a developer to have these kind of tricks up your sleeve, so that you know that you could kind of knife and fork your data into this kind of setup, so that you can at least prototype it at the start. So, as I said, the design approach that we're going to go for, so for this model, this middle layer, this business model layer, the model that describes your business, the kind of design approach you're going to use for that is the kind of Kimball approach. So who here has read or heard of Ralph Kimball at all? Okay, most of you. I imagine if you're here at 9, you've probably heard of Ralph Kimball. So, Ralph Kimball, popularised the dimensional model. The idea is that you have, one or more facts tables that contain the measures that you're going to be kind of adding up and averaging and so on. Your lookup data then goes into dimension tables, and then ideally the fact tables then share these dimensions such that they're called in the end a kind of a set of conformed dimensions. And the reason that's good is because you could focus on, for example, a set of customers that maybe have some kind of problems with paying their accounts. If you share your dimensions, then those same customers can then be used to analyse, say, the billing information. So the approach you're going to use is this kind of Kimball approach. And so that's the design you want to get to within your business model layer. And actually, this kind of support for the Kimball approach extends to things like bridge tables you can use and various kind of things there as well. So we'll look at some of those things later on as we go along. So your business model layer will contain fact tables, and they're typically kind of yellow in the model there, dimension tables, and also those little kind of little icons that look like dimensions. They're actually the drill parts, and they define the kind of logical kind of hierarchy within your data. So if you were kind of working with this, a typical kind of model that you'd end up with or want to work with would look like this. So on the right-hand side, we've got all the different kind of data sources coming in. So we've got some information from one system, from another, and so on. Then in the middle layer is when you simplify this. Okay, so where you kind of create a single model to cover the entire data set, and you put in, for example, some calculations and drill paths and so on. And then you end up on the left-hand side with all the individual views of the data for the different types of consumer that are in your organisation. So this is where it gets interesting, and the question is really, well, how do you go about doing this really? You've kind of got the idea that you need to go from potentially a set of non-star schema tables into a star schema. What's the best way to do this really? And really, just to kind of, just be clear, this is kind of my take on it. So other people do things differently, but this is something that I find works for me. And it means that I end up with a model that kind of works quite well and it doesn't go wrong and so on. So I'll go through this, but I'm happy to take kind of feedback and comments from other people. So if I'm going to work with a model in OBIE, what I would do first of all is, the first thing I would do is I'd kind of go and speak to the customers, speak to the clients, and draw up the kind of classic Kimball-style model to describe the kind of the data that I'm going to work with. So rather than focus on individual reports, what I would do is I'd talk to them, interview them and so on, and I'd then eventually come up with a list of candidate facts and dimensions and kind of levels and hierarchies to work with. And that's kind of textbook kind of Kimball-style business analysis. And I would use that information then to build up the business model layer, first of all, in my kind of system. So I wouldn't go charging in and start going around with this physical data. I'd go and interview the customers and then build up this kind of business model first of all. And that would then define the kind of data set the users want to work with. Then I would bring in my physical data, so I'd go and connect to Oracle or Teradata or whatever, and bring that into my sort of administration tool and define keys and so on. Then I would map the physical model to the business model, and then define calculations and aggregations and so on. And then I would go and create an initial kind of presentation model to show users. And then I'd go on to do calculations and so on there. So what I'll do is I'll step through here the various kind of steps I go through, and I'll show you also in the admin tool kind of what I'm talking about, so you can sort of see an example. Now, in the example I'm going to go through here, I've got some source data that I'm going to work with, and I'm going to really try and transform that into the kind of model that you'd want to work with. So in this example here, I've got some source data I've been asked to report on, and it's fairly kind of, if you're interested, it's actually from the SOA Suite demo you can download from OTN. And it's just a basic set of kind of normalised tables. So we've got an orders table, so an order header table, that then has one or more order items that link to it. Okay, so you've got a master kind of detail table there. Now the orders table has in this case it has a times table attached to it. It also has a customer table, and customers have addresses, and you get to the addresses through the customer address table. And then items are of a product, so each item is classified as a product. So this is typical kind of source data we'll be given to report on, and the problem with this is that that isn't in the kind of the star schema that you typically want to use in OBIE. So what would be our fact table data in this case is actually split over two physical tables. So really, in kind of dimensional modelling terms, we're going to create a single fact table, which we call like order items, that would have data from both the order header and the order detail within the same table. And I'll show you a technique you can use in a second to actually do this kind of denormalisation into a single fact table. And then what we're going to do is we're going to take the customer's data, the customer address data, and the actual addresses, and we're going to denormalise those into a single table as well. So our kind of objective in the end is to come up with, rather than that kind of more complicated schema, a simple kind of star schema on the right-hand side that will then work with OBIE. Now, if I just brought that left-hand data into OBIE, so I just dragged it all in and said start reporting against it would actually think that the orders table and the items table were both fact tables, and it would give me in the end one fact table called items with just dimensioned by product, and it would then give me a fact table called orders that was dimensioned just by times and customers. So the kind of scenario here is we've got some data that is not a star schema, and we're going to use some of the features of the administration tool to turn this into a more conventional star schema. So as I said, the first thing I would do is I would kind of not worry too much about how I'm going to do the transformation and so on. What I would do is I'd sit down with the business and actually kind of come up with the logical dimensional model that represents their kind of their business. So really the kind of the driver here, the kind of thinking is the model comes first. So we're trying to get away from kind of report-centric kind of data modelling to try and get towards a point where we come up with a dimensional model that describes the kind of the organisation and the way they analyse the data. Now say if you're lucky, you'll find there's a physical star scheme with the database that's exactly the same design as this, but 9 times out of 10, at least at the start, you've got to do a bit of work to get the data to look like that. Okay, that's what we're going to do in a second. So when I come to do this, what I would do is I would define a new business model in the administration tool. So I'd go to the middle layer, define a new business model, and I would then start modelling out from the fact table. So I define the facts first, and then I put all the measures in the fact table, and then I define the dimensions after that. Okay. Now at that point, if you were to do this modelling, you'd end up with what the BI administration tool thinks is it's like kind of 5 or 6 actual fact tables, because at that point they're not joined together in any way. So what you have to do then is define what's called logical joins between the logical tables. So at this point what you do is you go into a little kind of feature of the tool where you can diagram the joins between the tables, and you would create new logical, or in this case they're called complex joins. So you define what are called new complex joins between the logical dimension tables and the logical fact table. And when you do these complex joins, you don't specify what the join column is. Okay, so you actually just say, you know, I'm just going to do this table here, has a one-to-many relationship with the table in the centre. And then what happens then is that later on, these kind of joins get picked up by the, what happens is, the joins then tell the BI administration tool there's a relationship between these tables. Now, when you define the physical joins in the physical layer later on, they're actually used then, they're the bits it refers to, and it works out on what columns to join the tables through. But I'll show you in a second, it's probably easy to demonstrate it to you and actually talk about it. But the key thing is in the logical layer, you define logical joins between the tables, and it just establishes a relationship between them. Then you go in and define the physical layer. This is where you do the import in. So you import the physical metadata about the physical tables into the physical layer. And a really important thing here is that you define the keys properly on the tables. So you go and make sure that every physical table has a physical foreign key defined. If you didn't pick that up on the way in, then you can define that within the tool. And there is a kind of school of thought that says that just don't bring any keys in at all, just bring the tables in and then define the keys yourself. Okay, so you define the keys there and also the kind of foreign key relationships as well. And having this set up properly in the physical layer means that everything just works much better later on. There's a lot of the stuff that you do later on, like say those logical joins you set up in the logical layer, they rely on these physical joins being set up properly. I'll show you in a second, and hopefully you'll get that. And then you do the joins together, so you would join the physical tables together, and so you end up then with a situation where you've got a logical model of logical tables that have been logically joined together, and you've got a physical model that's got physical joins, okay? And then you go through the step then, and this is the kind of clever bit, where you take your physical model and you map it onto the logical model, okay? Now what I do, I actually kind of show this to you now, because it's probably easier than trying to explain it. So, excuse me. So what I've got here is let's just see if this works, hang on. So full screen. Okay, so this is a kind of sample setup that I've got here. So, excuse me a second, I don't know to go. Right, okay. So, in this administration tool I've defined, so rather than you sitting here and watching me kind of type everything in, I've gone ahead and done the definition already of the logical model. So I've sat down with the business and I've established that in the model that I need to build to support their reporting, I need to have 1, 2, 3 dimension tables, so customers, products and times. I need to have one fact table called order items. Okay, so I've gone ahead, I've actually kind of modelled out and designed these previously prior to this session. So you see here, the order items has these kind of key values here that link it through to the dimension tables, and then I've also got a couple of measures in there as well. Then the dimension tables here have got their kind of attributes in there as well. So going back a step to when I said about the logical joins, the first thing I have to do with this logical model is to actually tell it about the relationship between the tables. Because at the moment they're all in yellow, and that means that the administration tool thinks that in fact all of these tables are fact tables, and that's because there's no joins between them. So I'm now going to go and select all of these, right-click, business model diagram, whole diagram, and then I get this kind of diagram on the screen here. So I've got times and customers and products, where are we? Products here, and order items. Okay, so order items is the fact table. So at the logical layer, all I do now is just tell it about the relationship between the tables. I don't specify in these joins the columns to join on. That's picked up from the physical layer. So if I now go and select new complex join and go times to order items, you go from the dimension to the fact table, that now creates a logical join. It's a bit confusing because on the kind of the toolbar it says complex join, but when you come to actually create it, it says new logical join. I tend to think of them as logical joins. Okay, so click on yes, I've got one there, and then I go from customers to order items there, just say yes. And then I go from products to here. And the reason you don't specify the columns on which you're going to join on in this layer is because actually later on you might end up mapping additional tables into the logical table for different levels of aggregation, for example. And if you've got a table coming in, a summary table, that basically starts at the product category level, then it wouldn't make sense to kind of, if you can't join that table to the fact table on kind of product ID because it won't exist in there. So if you just tell it about the relationship between the tables, the tool will then look at the actual kind of level you're aggregating at and the different joins in the physical layer, and it will pick the most appropriate column to join on at runtime. Okay, so that's why you end up just defining logical joins here, and then you just leave the kind of the definition of what column to join on. The BI tool does that as the most appropriate way when you're actually kind of running the query. Okay, so now you end up in a situation where you've got one fact table now, and you've got these dimension tables, products, times, and so on. Okay. What I've also done is kind of defined the actual kind of drill paths here as well. So we've got customer dim, country, state, and so on there. And later on, what I'm going to do is I'm going to basically map my logical kind of tables to this drill path so that users can then drill up and or drill down the data. So now I've kind of done this process where I've kind of built out the model here, and this represents what the business wants. And also then go afterwards and do file import from database, and I bring in the metadata for the physical tables that contain the data that I want to report against. And if you see on the right hand side here, we've got address, customer address, and so on there. So this is the reality, this is the actual tables that contain my data. So the challenge for me as a BI administrator now is to take this physical data and make it kind of map on to the more simplified, denormalized kind of data model that's in the middle. Okay? So that's one of the challenges you have. And in particular, this fact table here, order items, okay, it gets its data from two of the physical tables here, so items and orders. So yeah, how do I do that? How do I map these two tables in to my one logical table? And what you do is you use a feature called logical table sources. It's one of the things that it's quite hard to explain how this works at the start. It's kind of a bit of a confusing feature. But if someone shows you, hopefully it will make sense. So, okay, if we look at order items here, so this is the fact table, and it gets the data from two physical tables here. So the way I kind of map this in is I'd start off with one of the tables. So in this case, I'm going to start off with the items, so the detail table. And what I do is I map in the columns that are here. So if I map in, for example, item ID, if I just drag it across now to here, that will map that in, and that will now, if you notice, this little folder here, which is the sources for the logical table, now has an entry there called items. Okay, and that what's called a logical table source, that now connects through and points through to this physical table. Okay. So I can do the rest, I can go do orders, for example, so order ID goes in there, and product ID goes in here, and where are we here? So quantity goes in here, and price, and so on there. So if I now double click on this logical table source, and then click on the column mappings thing here, we can see that in fact of that logical table, all but 2 of the columns now have been mapped across from this detail level source table. But the problem I've got now is I've got customer ID and day ID. They aren't found in the order details table, they're found in the orders table. So I need to find a way now of bringing those new columns in. So the way I do that, what you think first of all, and the thing that I tried first of all, was just to kind of go and get the orders table here and start, for example, dragging across the columns. So if I go and get, for example, order date and drop it onto day ID, right, what happens now is that a second logical table source gets added to that table. Now that actually tells the BI server that it needs to create 2 SQL statements to get the data for this table. So it's going to now go, if I went and tried to run this, it would generate an SQL statement that gets data from the orders table, and an SQL statement that gets data from the items table. And so you're generating twice as much database activity as you should do. And then it probably will end up having problems trying to combine the data as well. So what you do instead, the actual correct way of doing this is that you would just take this out here, so let's go and delete that out. Okay. What you actually do is instead of just dragging a new table source into that table, you edit the existing logical table source because both source tables exist in the same physical database and actually can be accessed via a join instead. So what you do is you go and drag, let's have a look here, you go and drag edit this, and what you do, the logical table source currently has one physical table mapping into it, which is the items tables, that items physical table. What you do now is you click on add, and you can now map in any tables that join to that physical table, the physical layer, and then you can bring in the columns from that table into your logical table as well. So if I click on orders, so now my logical table source actually maps to 2 physical tables, and they're joined to the kind of physical layer, and so having those joins in place in the physical layer is kind of important for this. And so you've got items and you've got orders there. So now I can kind of legally go and take columns from this second table now and map them in. So I can go and get the customer ID and drop this in. If you notice now when I do this, it doesn't add in a new table source because it knows that you can get to that second table via the original logical table source. So we've got the order ID there, so customer ID and the order date. Okay, so if we now go and put that in there, so day ID, like that. So what I've done now is I've denormalized these 2 physical tables into one logical fact table. And that business of using logical table sources is one of the kind of key techniques to understand with this, because it's one of the key things that lets you denormalize more than one physical table into a single logical table. Okay? So working that out is kind of important. And it can be a bit confusing because logical tables can have more than one logical table source. Okay, we'll come on later on to when that's valid. Okay, but then each individual logical table source can have more than one physical table mapped to it. And that's what we've just done now. And that allows you to denormalize several kind of normalized tables into one logical one. A bit complicated for 9:30 on something on a Tuesday, isn't it? But hopefully you kind of follow that anyway. And you do a similar thing with customers as well. So customers at the moment, most of the data comes from the customer table, so we get the customer ID coming in here, the forename and so on. But then because some of the data is held in other tables, it's held in the address table and the address intersection table, what I would do there is I'd go and edit the logical table source, and I'd go map in then first of all the customer address table, and then that then joins the address table. And so it means my logical table source for that table then covers several kind of separate normalized tables, and that's a key technique in doing this kind of simplification. And so you follow this through and you kind of work through all the tables that are there. Okay, so let's move on. Now one of the things to bear in mind here is that, it's very clever and you can kind of do all this kind of, virtual denormalization and so on there. But, just think about in the end when you're doing this joining. So it makes, at the end of the day, if you've got this kind of very complex model and you've then simplified an OBIE into a star schema, then, that's kind of good, it lets you prototype stuff and so on. But at the end of the day, if you can physically denormalize your source data, so if you can physically denormalize it into a star schema using a tool like Warehouse Builder or Informatica or OBI, then at the end of the day, you'll get better performance out of that. So this is something that you would do probably initially to let you get some data into the system, but your objective long term should be to turn your physical data into a kind of representation that's as close to this as possible. And that's why you see kind of physical data warehouses, and that's why there's so much value in the Oracle BI apps that do all this work for you, really. Okay, but as I say, this is a good way of getting yourself